All right. So, whoops. And of course, it just stops right now. There we go. Excellent. So, no, that is not a silly question at all. And the answer is there are going to be some labs, but they're not going to be as we're going to after lab. So here, let me share my screen. This should help explain it. I'm planning, this is still a bit in flux because I plan on reworking it a bit after this week. So you'll notice that I've got Hawaiian pronunciation, and then we've got pig for our next lab. And then over here, we have a few more things. And this is going to be a bit more self-driven. But you'll notice that I don't have too many more labs over here. I might throw in one about gerrymandering because that works with our file reading stuff. But for the most part, after week 10, we will be focusing on giving you the tools you need to succeed on your final project. And this class is still in flux. I need to figure out in the sense that like, you know, I haven't settled on exactly how I like the last third of the semester to be good. Can you use list comprehension on the labs? Yes, so long as you can explain that you're using it. List comprehension is one of those things that basically that like lambda expressions that are, because I don't go over it too much. It's one of those things that basically lets me know you might have grabbed it from the internet somewhere. So, but if you know, yeah, so explain it in a comment or be ready to say it when you demo it. That's all. So, you know, so once we talk about, but anyway, after we get to, once we get to like week 11, I'll talk about different things that are available in Python to help you out. I'll talk about different things for making games, point you in the direction if you want to start making a mobile app for your final project or a web page or web app for your final project. So there's a lot of videos and everybody's going to probably want to do something different. So there, but the final project basically takes a couple of different stages. You do the pre-proposal where you're going to tell me what you're thinking about doing and your TA, and we make sure that that is not too trivial or too hard. Okay. Then we have the proposal where you propose what you're going to do. Specifically, what you do is you say in 3 sections what you're going to do, what you expect to get done no matter what you hope to get done, and what you're going to get done if all the stars align and there's no issues in production whatsoever, which would never happen, but you know, basically what it is. Andrew, yes, but you got to throw it by me first. Okay. So with the dropping a lab, give me a second. I can get to that in just a second. So right now I have a rule currently in place to drop the 3 lowest scores in here. And that's for the labs and any of the active learning exercises. That's apparently what I have. So, except that, let's see, it may end up being, oh, it probably has to do with the whole Pong thing. So there'll probably be 1 drop lab effectively. No. So the final exam, so these are all different categories. You've got solo exercises, active learning exercises, you've got your quizzes, and then we've got the final project and the final exam. The only way you get out of the final exam is by having one of the best final projects. So now just kind of brainstorm stuff that you want to think about. I'll show you some projects I think were cool, by the way. And there's nothing, you don't necessarily have to do something original. You can take something that you've seen and think is cool and add on to it. And I'll show you explicitly one. Will the final exam be online? Yes, it will be. Yep. It's one of the web app thing. It's one of the things you can try to do for a web app. So yeah, anything that's labeled under solo exercises or was an active learning exercise that was done in the book, like the stuff we're going to do today, that can be done afterwards, and that'll be hit by the grader. The quizzes, on the other hand, won't. Is the final open? Yeah, because I can't really monitor everybody's internet usage, so we'll see. Okay. Yeah, we'll be open book. So, okay. So anyway, let's talk about today's activity. But suffice to say, I'm going to figure out what we're going to do here. And I want to just point out, and we're going to figure out what we're going to do here. I'm also going to show you how to use GitHub as well. But there's just like once we get to like module 11, a lot of my lectures are going to be more traditional lectures. Yes, I'll make one for the request for quiz 3 tonight. Okay. So let's go ahead and talk and look at the and I'll still try to add more projects like this as we can. But let's see. I haven't run the grader for quiz 3, but it should be able to have graded. I will when I create it. Oh, drop the link to the object, to this thing. Got it. All right. So today's exercise, I'm dropping the link in chat. Okay. So you can also find it linked in Canvas under your modules. Under the module overview over here, dictionaries. And we'll do, and click Tuesday. Okay. So today we're going to be talking about Zipf's law, which is a law about how common things can be, as far as I understand. So yeah, a common way to describe Zipf's law is that words are not evenly distributed across text, but rather there's a few words that are very common and a lot of words that are very rare. For instance, the word "the" is a very common word, right? Not every is like, so we've got a dictionary full of English words, right? But not every word is as frequently used, right? There is so one of my favorite books is by the author Randall Munroe, who does the webcomic KCD, and he built a book based off of this comic, which was called Upgoer 5. So basically it is a explained using only the 1,000 words people use the most often. So every word in here is one of the most common common words that are used, one of the 1,000 most common words. Basically, he had to use so this is for the Saturn V rocket, and he was basically describing its operation in terms of the most, this very limited vocabulary. Part that falls off seconds. More breathing type air for burning, cold plus wet. In other words, it's more oxygen goes in this tank for burning. So it's oxygen fuel, cold and wet. More funny voice air, that's helium. So and he did an entire book. So King Explainer, which basically just kind of extended that more. Okay. So but point being is that words are not all evenly distributed, right? And if we but if we do something, we will get a log. And if we plot them, we will get a log scale. Okay. So what is the most common the 10 most commonly used words? How does the frequency of the word of usage of the most common words compared to the least? What percentage of usage the 25 most common words represent? Does everybody kind of understand what I'm talking about by most common and least common words? Or have I lost people already?
No, I understand. Thank you.
Mm-hmm. So other fun questions that we'll look at, which of the words spelled forward are on the list that are also spelled backwards? You know, so top and pot are both on the most common word. So here we've got data. This data was from, I'm not really sure. From the word frequency data project. From the word frequency data project. And we're given a CSV file. So this helps us. So the entire point of this is to help us work with reading files and working with them line by line. Specifically, we're working with a CSV file. Again, that stands for comma separated value. Now let's read the data. Each word also has a part of, so here we've got the rank of the word, what the word is, part of speech, frequency, and dispersion. Okay, so what do each of those mean? So frequency is that, like in the text, how often it occurs. So the occurs a lot, as we can see. It occurs in what they in the files they analyzed. It occurred 22 million times with a dispersion of 0.98. Basically, if it's one, if you find it, a one means it's basically this word is used a lot. Everywhere is used a lot in basically every document, whereas 0 means it's basically shows up a lot in only a few documents. So the example they have is the word re, R-E, meaning it occurs 15,000 times, but has a dispersion of 0.747 because it's primarily used in legal writing as opposed to anything else. And then let's see if we can't find another point. Furthermore, right? Not really used too much in that. Institutional, that's distributed, but I mean, it's like you're finding that you're not really finding institutional in novels per se. Quarterback, only if you're talking about sports, really. So we can see that kind of stuff happen. So we've got a bunch of words here, and it's a file. It's loaded into the background of your computer if you're working on this. Also, the last thing, these letters, again, parts of speech. We've got, A for at, we've got a single letter for each of these, article, verb, C conjunction, I preposition, T for the infinitive too. Let's see. So here, T, 2T, for the infinitive to. So basically, these are each different things. What's the word? What's the letter in front of the word? So you've got the letter, and then we've got the part of speech. Okay, no worries. So let's go ahead and, so the first task is to read the file and store the contents into 5 lists. So remember, as you read each of the line, the line will be represented as a string. Your goal is to split the line into 5 parts and put each of those parts into the appropriate list. In other words, our task here is to we have the rank, the word, the part of speech, the frequency, and this distribution. So we want to read the file and store the contents into 5 lists. So, okay, so what we want to do is that we'll want to make 5 lists. Rank. Hey, what am I doing? I've got this. Let's go ahead and just copy this over here. Rank, word. I'm going to go with part. And to just frequency. And then dispersion. So those are the things we want. Control C, Control V, Control C, Control V, Control C, Control V. Right, but all right, so let's go ahead and now read the file. And so we want to split each line. So because we're wanting to split this each by, so because now remember we have 3 ways of reading this, okay? So what is the first thing we have to do to read a file? Yep, got to use the open command. Open. So what we're going to do is we're going to do open, and then we're going to do, and then we need the file name over here as, so it's words 5000.csv. And then R, and then R for read. Save and run just to make sure that it works. It does. Great. I'm going to make double sure that it works. And I'm just going to put in a print done over here. Great. Okay. Even though we're not done, I know I'm totally lying there to the computer. How dare I? Okay. Now we need to, so now to actually, now that we've opened the file, we want for reading, we actually have to read it. Now, remember, there were 3 ways. What are one? Give me one of the 3 ways, each of, or I'm sure I'll get all 3 of them if I ask that. So read lines, a loop, and then what's the other one? Yep, turn it into a big string. Okay. Yep, so we'll do with the last one. The first thing I could do is I could just load up the entire file and store it in a giant string using using the read function. This is less useful though, because we need to go line by line, right? We want to read each line of the file over here so that we can split up the line and like separate it out, right? We want to put all the words into word, all the ranks into rank, all the parts into part, and so on and so forth. That makes sense to everybody? So reading the entire text file like that, that's just making more work for us to do. Text is equal to read lines, or text is equal to data.read lines. Seems like a pretty good idea because that separates it out into lines. Personally, I've always been partial to a for loop, for line in data. And boom, just like that.
I was going to say.
Sorry. Yes, Ezra.
Oh, sorry. That's what I say. Make a for loop into it.
I'm going to go ahead and pass this. And now okay. So, and before I give it to you to work on for just a second, I want you to, let's go ahead and think, okay, so if I read this line by line, I'm going to get something like this, right? If I read a line is going to look something like this, right? Where I've got a number and this. Now, fortunately, they're all separated by commas, right? So how many of you remember the split method?
I think I used that in a for loop recently to separate it by comma.
What we'll want to do is line dot split, and then basically we can do that. Line dot splits to turn it into, yeah, I essentially pass when I don't want, when I just want to leave it blank for a second. Lines dot split into these. All right. So let's go ahead and we can split the line into parts like that. So go ahead, I'm going to share the code and now take 5 minutes to work on it. And what I want you to do is to, now that you've got each of the parts, put the appropriate parts into the appropriate list. All right, so I'm not going to bother separating you into breakout rooms for this one because that's pretty short. I just want you to take like 2 minutes here because this part's fairly straightforward and is copy pasting. Yep, when you split it, it is a list. So parts is now a list. So I'm going to give you 2 minutes to work on it, and then I'll explain this part, and then you'll get a bit more time to work on that part. Okay, 1 second. All right, so what we're going to want to do is we take our code and we just basically append each of the parts. So what I'll do is I'll put in rank. I'll do rank since rank is the first thing in our line, I'll append parts 0. And then the benefits. Okay, and now 1, 2, 3, 4, because we want to append all the parts, and there's 0, 1, 2, 3, 4, because there's 5 things in there. And then word was the next thing, part was the next thing, freak was the next thing, and this was the next thing. We'll go ahead and test it. We'll go ahead and test this by printing by printing out Word. And we've got Word. Aha. So we do have a bit of an issue, which is Word, the B and of A in. So we have the very top bit over here, which is a bit annoying. We've got this as part of it. That we've got our labels. And yeah, so that's the first thing. Now let's look at the next thing as somebody pointed out. I want to also test this one. Disp. So we print out disp, we see that since they are on it's on the end of the line, it comes with the new line attached to it. So we can do a bit more. Let's do a bit more cleaning up here, because that's where I expected you to get to realize, okay, I've done it, but there's a bit of an issue, right? I read the file. Oh, but there's a new line on the end of the last thing because that's a new line. There's a new line as part of the file. And oh, we still have the label. So let's take care of getting rid of the label. Okay. So normally I would get rid of that. I thinking to myself, because I'm thinking in Python right now, I should use a slice. Right. Start from the one, go to the end. But if we try this, you'll see that it says file does not support indexing. Okay. Ooh, but what I could do is I could do this. Data.read lines, which basically, right, this turns it into a list. And then I can say for every line, I only want the first ever line. That's one thing. And that gets rid of the first thing. Now for this, there's a couple ways we can get rid of this. First off, note that this is a floating point value. So I could always just simply do this. Right, I can put float around here and int around here, which seems a bit useful because I'll probably want to treat those as numbers, right? Bad input on line 14. What did I do wrong? Oh, okay. Oh, I see what I did wrong. It all goes back to the previous line. That was super useful. And now they're just numbers and they don't have that there. But what if you wanted to but yeah, as Corinne pointed out in chat, another way we can do that is we can do some cleaning up over here too by saying line is equal to line.strip, which gets rid of any preceding or trailing white space. So if you have a bunch of spaces or an enter at the end or at the beginning, it will take care, or tabs, it will take care of anything before or after text. And they're now numbers. As a bonus, I ran across this XKCD that many of you on liberal art campus may enjoy. Frequency of the, so this, but let's see. Yeah, frequency of the word sustainable in English text as percentage of all words. So notice that basically sustainable has become, has started going up more and more. And if we plot it out and extrapolate, then sustainable will occur once per page in 15 years time. By 2061, sustainable is basically going to be occurring every sentence. And by the next century, all sentences are just the word sustainable over and over and over again. I can do better. I'm going to share it.
It is things that if we're still going to be alive at 2160.
2109, but yeah.
Whatever.
All right.
I mean,
so now let's explore Zipf's law, which is, again, this is in a log scale, which means that, that means that basically we've got logarithms on both the y and the x-axis, I believe. So So anyway, yeah, if I've shared it, then you reload the page. If I've shared the code, what you're going to want to do is press F5 or whatever to reload the page. And then go over here and hit load history. All right. So now calculate the total usage for the top 10 words in the list. Store this result in a variable called top 10. At the same time, calculate the bottom 10 words in the list and store that in the bottom 10. So the usage percentage. In other words, we have this giant corpus of data. Frequency, and in other words, and we know how often each of these words appear. So what I want to know is for these top 10 words, how often do these appear? How often are they appear? Is stripping necessary? No. And then we'll want to use that for the bottom 10 as well. So let's see, save and run. Do we have anything in here? Print. So we will want to copy. So we'll want to use what we have here to start with, first off, because we need to have all this data. Right? We'll need to have, especially this part. So we want to know what percentage and here now what we're going to be working with specifically is this list over here, which is not word, but frequency. We want to figure out how often, what percentage are the top 10 words in the list? What percentage are the bottom 10 in terms of usage? Okay, so I will give you, I'm going to again share this code. Go ahead and take 5 minutes on this one. And if you can't get it, don't worry. I just want you to really think about it too. All right, let me split you up into breakout rooms for this one. Breakout rooms. I try to, if I don't upload it this day, then I upload it the next day. So if I wasn't worried about copyright strikes on my channel, I would totally be playing the Jeopardy theme. Well, the breakout rooms are coming off. All right. So what we needed to do is that we needed to figure out just exactly how many words total there were to begin with. So, what we could do is, because I went ahead and put frequency dot append and put that in integers over here. I could do sum frequency and say, hey, nums is equal to sum of the frequency, run it. Yes, I know. Top 10 is not defined. You're really upset about this. Okay. Fine. I'll create a top 10. Top 10. Bottom 10. Okay. Run. Unsupported operands for list and for minus list and float. Oh my. I am a bit exhausted. Let's see. So, yes. Sorry, I thought it wanted the top 10 words. Why did I think that? 0. Didn't run. Okay, great. So now, yes, I'm making a number of mistakes, and I can chalk, and thank you. I'll just simply chalk that up to being tired. So this is the total number of words we have. So that is 508 something, 29 million, something, 508. A lot of words. Total words. Okay, so now that we have that, it's not too bad to figure out how often these first 10, it's actually pretty easy to figure out how often the top 10s occur. What we need to do is we need to do top 10. And all we need is we need the first, freak. Okay. So what do we need? We need freak. We need the first 10 values of frequency, because that will be the first 10 words over here. 1, 2, 3. So that will give us the to it, all very common words. And so to get the first 10 values, what we're going to do is we're going to use a slice. That will give us the first 10 words. We sum that up. And now what we can do to get the percentage is that we just divide by the total number of words. And that will get me top 10. Which did. Bottom 10, we do in a similar manner. Only instead of summing up the first 10 words, we're going to sum up the last 10 words. So negative 10 to that. So what does this mean? So what does this data tell us? This tells us that the words the, be, and of, in, to, have, the infinitive to, these, and it, these 10 words make up the 27% of all written words. 27% of all words are one of those 4. Those are one of those 10. Now it is, yes, if I did, the reason I put in 10 over here is because that gives me all 10 values. It gives me the indices 0 to 9 inclusive, or 0 up to, but not including index 10, which is 10 numbers total. Make sense? Now here's the other thing. Now negative 10 over here, yes. So remember, negative values, one second. Negative values in Python for indices, they basically go around the end again. So going back up to here, if this is index 1 over here, sorry, if this is index 0, then this word till is index -1. This is index -2, index -3, index -4, index -5. So using negative indices, you can use index -1 to get the last item, index -2 to get the second to last item, and so on and so forth. So -10 basic up to the end gives me the last 10 words. Very useful. Very, very, very useful. Now those last words, which include apologize and till, they don't even make 1/10%. They make up a 100th.5%. Sorry, no, 1,000th.5%. So these words are not too useful. So just to get a sense of the distribution, let's use Altair to graph the frequency of words on the y-axis against the rank of the words on the x-axis. Now, I did not do Altair this time around. I just didn't show. So give me 1 second and I can pull up my code from a couple semesters ago. So share this code with everybody. And we can see this on a graph, essentially. I'm going to show you that there are some really cool graphing programs we can use in Python. So again, this is actually going to be built in to your to Runestone. So let's see. Joink. And exploring common words. Okay, give me a second to change course back to here. Okay, so I'm going to just paste some code in. It's going to look like magic. Don't worry about it, though. So, but I'll go through and explain it because I don't really use graphing too much and I don't use Altair this much, but Altair is a graphing language. So if we save and run it, we're going to see though that it can produce a graph for us, which is pretty cool. So let's go ahead and look at how it does this, because again, this is pretty cool that this is just built in and something you can do for your web browser. So here, right? Data. So the code I had wrote 2 semesters ago looks fairly much the same, except over here I said data is equal to data.readlines, and all that did was replace that so I could do the slice over there. And all I need to do to make that like our current code is just simply drop this over here. And then I went ahead and I just did the line is equal to line dot split rather than doing parts. And so what we did over here is you'll notice that rather than using the so let me go ahead and just simply modify this and keep it comment. But what I did was I used a logarithmic. I took the logarithm of this. Append line there. I know your eyes are going to be starting to scare. So add input on line 10. What did I do on line 10? Bad input on line 18. Yes, I totally just simply mangled something. Okay. Bad input on line 19. Yay, I'm really on top of things today because I forgot to close my parentheses. See, I'm still capable of making very strong errors. So this is what the graph looks like. And you notice that this is kind of a useless graph. What are we graphing over here? We are occurring the ranking over here versus how often these things occur. So rank 4,000 words, we can see don't really come up all that often, whereas these first rank few words come up really often, so much that they break the scale, and it's kind of useless. Yes, I will share this code. Why am I importing Altair? Because without it, I'm not going to be able to do any graphing over here. Okay. And so I'll get into how that works in a second. Sorry, I just want to go on a side, and before I talk about this, how many of you freak out when I say the word logarithm? Like, I know you know what a logarithm is, what a logarithm probably is, right? So let's talk about what in world a logarithm is without actually talking about the exponential logarithmic relationship, because that's useless. It's utterly useless. I'm sorry to all mathematicians in the vicinity of me, but the fact that logarithms and exponents, you can transform one to the other through an equation, that's useless, utterly useless. It does not tell you what a logarithm is. A logarithm tells you how many times you can split something. That's how much what a logarithm does. Okay, what do I mean by that? Well, let's work with let's talk about logarithms in terms of the most sensible logarithm, a log base 2 logarithm. Okay. So, what does log base 2, and the reason I'm talking about log base 2 is because we use log base 2 in computer science all the time. So, okay. So if I want to know what the log base 2 of 16 is, and I'm just going to work with things that are evenly, that basically, if you throw it into the logarithm equation, it gives you a clean number, gives you an integer as an output, because otherwise my examples break down. But that's okay. So here, what we've got is we've got 16. What log base 2 asks is, how many times can I split this in half? How many times can I split this into piles of 2? So I can split 16 into 2 8s. I can split each of those 8s. I can split an 8 into 2 4s. I can split a 4 into 2 2s. Can split a 4 into 2 2s, and I can split those 2 2s into 1 1s. Sorry, those 2 2s into 2 1s, right? So, right, I can split the 16 into 8s, the 8s into 4s, the 4s into 2s, and the 2s into 1s. We did 1, 2, 3, 4 splits. So log base 2 of 16 is 4. That is what a logarithm is. It is asking you how many times you can split things. Log base 2 asks how many times you can split things in half. Does that make sense?
Yeah. So a log base like 10 would be how many times you could split it in 10.
The piles of 10. Yep. That's why I can use this example. So if I split, let's use 100 for example. You can split 100 into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? It can become 10 tens. That makes sense to everybody, right? A 100 is 10 tens. We can split into 10 tens. 6, 7, 8, 9, 10. And we can split each of those tens into 10 ones. Right? Excuse my horrendous drawing. I'm just going for speed here. So log base 10 of 100 is equal to 2 because we can split 100 into 10. We can split 100 into by tens twice. We can split 100 by tens twice. We can split into tenths. There we go. That is the word. So now the reason mathematicians don't like this, of course, if I ask, is that it doesn't really cleanly answer the question of what if it's 101. And the answer is, well, it's a bit more than 2, just a tad bit more than 2, because you have that little bit that's been split up into all the other ones. But it works for your base 2s. It works for your powers of 2s. It works for your powers of 10s really well. It's a really good way to think of this. So when we do a logarithmic graph, sometimes when we have data that looks like this, that's the one that I grabbed it from. When I have data that looks like this nonsense over here, it's sometimes just more useful to take the logarithm of this to see what it looks like into split into 10, just to give it a better scale, to make it look graphically a bit cleaner. And so that's what I'm doing in this line. I'm basically applying this logarithm operation on it to make it look cleaner. Okay. And basically what this means is that this is not 0, 2, 8, 6, 10. This is like to the frequency to the power of this. So 10 to the power of 2, 10 to the power of 4, 10 to the power of 6, 10 to the power of 8. So that makes it a bit easier to see just graphically what's going on. Okay. And also, since they're powers, going up is just like on the earthquake scale. Just how intensity going up by a single point means a huge difference in damage. All right, so Altair, what did I do here? Well, to graph an Altair, you can check that out in one of your other projects over here, which is graphing Kiva data with Altair. There's a lot of different graphing options available. However, Altair was designed to work in the browser, so that's why the book uses it. And it can create a whole lot of different graphs just very quickly like this, which is useful if you've got the data like this. But to create a data like this, I just simply say, hey, I want my X data, I want my Y data. So I say ranking should be the X data, frequency should be the Y data. So I say this label is equal to this list. This frequency, you don't need to know this, by the way. I'm just explaining what I did. This frequency is equal to, this frequency data is equal to this. The chart over here, that is what we're printing. How do I want to graph it? I'd like to graph that chart with a line. And what should I put there? Well, the rank wings and the frequency, please. And please display it. So yep. And then log of the frequency, and then the log And then we can, so we can take the log of the frequency. Yeah, we can add more columns to the table if we wanted to. So you can play around with that if you want to. But I'm not really here to do graphing data. I want to focus more on string manipulation right now. But it's just, I just wanted to show you that this is a feature that exists. I also wanted to take a chance to explain logarithms because I know how awful, just how lost I felt about logarithms when I was in university. And in computer science, it way more makes sense to think about it in terms of splitting. Especially when we talk about algorithms, because essentially you reduce, so what, like when you have an algorithm like binary search, which we call log base n algorithm, that means that it reduces our search space by half each time we take a movement. So I think the reflections, by the way, I think the lights are reflecting off my glasses, and I'm looking at my own picture. It's making me look a lot more tired than I actually am, because it's like making look like my eyes are closed. Okay. So you can probably come up with interesting questions about popular words. What words when spelled forward are also on the list when they're spelled backwards? All right. So let me go ahead and give you load history. So I want you to find what words of the 5,000 most common words, what words were spelled when spelled forward were in the list and are also spelled backwards. So print, I'm going to share this so that you can work on this. Done. Share code. There you go. So, so for instance, pot is on one of the most common words. And if you spell it backwards, you get top, which is also on the list. So what words are basically palindromically a member of this list? All right, so I've shared the code. So go ahead and take 5 minutes to work on that. Breakout rooms, recreate, open all rooms. This is Final Jeopardy. Having trouble with this category. Today's champ won't be me. Don't know Greek mythology. All right, so there you go. I believe I've shared. Okay, you want me to share the code in chat? Okay. There's the code shared in chat. Right, so the breakout rooms are closed. Everybody is back. You've had to listen to my horrible singing. So there we go. There we go. So we want to find what the most common words, what words that are in this list that are spelled both forward and backwards. So we can do that by looking at the word list. So for W in word, so we want to figure out if it's reverse. We'll call it backwards. If so, backwards is equal to W. If and then how do I do it backwards? This is the easiest way to reverse a word right over here, I find, which is to take the slice of the slice or substring of the word, but do it in reverse. That is something very useful that you should know. Colon, colon, right? From the beginning. So, right, leaving this out means from the beginning, in the middle is to the end. And how do we want to get there? Normally we go up by 1. This goes down by 1. So this goes to the end. So print. So if backwards in word, print W. So let's go ahead and run it. Oof, okay. That's interesting. Come on, computer, you can do it. I know you can. There we go. Dumb reading. AI, no, O. So on, known, no, on, part, live, I, level makes sense. Refer, pool, mom, dad, part. Okay. So now there are a couple of issues with this. Primarily, so first off, let's allow palindromes. So things like level and A, those can, and refer, those can stay in. In other words, the things that are spelled for the same forward and backwards. But notice that we've got on, no, and on added in there twice, as well as no multiple times. So let's go ahead and basically make a list instead. List is equal to a list. And what I'm going to do is that I'm going to say, hey, if I find a backwards word, so if I find a word that's in this list and it's both forwards and backwards, I'm also going to say, and not in flipped, and backwards, not in flipped, flipped dot append backwards. What this will do is that this will limit the words we have to just being this. Not sure why this one is taking a particular, oh, because of my not in check. Yes. Takes a while. So here we go. And we see that basically we don't really have any repetitions anymore, which is cool. Share code. All right, now for the final question we want to try before we go up to the, before we end the lecture is how many new words can be reversed if you add an S onto the end? For example, an S onto the end of pot as after you then reversing it gives you stop. Okay, so that doesn't really require too much of a change. What I'll do is I'll say for word and word. I did. W is equal to W plus add an S to the end. How many? And now we can say, hey, run this and see. And we should get. And it's just hanging like this because of how long it's taking to go through. And so no, when reversed became sun. We got spot, speed from deep, tip, a spit from tip. So that's pretty cool. All right, I'm going to go ahead and share that code, and that's what I have for you today. Hopefully this helped you understand how to do, hopefully this helps you understand how to do a bit more with file reading. On Friday, so not Friday, on Thursday, what are we going to do? We are going to go ahead and work. This is linked on Canvas under Thursday, but we'll be looking at converting Roman numerals. What we're going to do is that we are going to look at the way at basically how to convert from Roman numerals to Arabic numerals, and then from Arabic numerals to Roman numerals. Okay.
So when are we going to learn about dictionaries? Is that next week?
That's this week. These videos are about dictionaries.
Okay. What about are we going to do like some dictionary examples in class?
The current, yes, that we'll be doing converting Roman numerals. That's going to be using dictionaries.
Oh, okay, gotcha.
And then the assignment for this, the Hawaiian pronunciation lab, is the dictionary assignment. You'll be solving that using a dictionary.
And when is that due?
That's a great question. Yes, it would be very good to read about dictionaries before the lecture. It's due the 23rd, unless you're in the Monday lecture. That gets a bit of extra time because they are they're on a lag.
So if it's for the Monday sections, due the 29th.
Yep. Kayla, I saw your email. I was going to email you back. But I did see that. I won't be able to check your password, but I can reset it for you, and I will do so. Okay. So with that, I'm going to stop sharing and stop recording. Don't worry about the 7th activity. I'll make sure that it doesn't get counted when I grade, when I put in the grader.